is an exercise illustrating how to create a conceptual model. But first, a short background to show what a conceptual model is and what method to use to create it. So the conceptual model is a model illustrating the data existing in the reality that we are currently considering. So we create a model which shows all data that is to be stored in the database when we come to designing a database. But the purpose of the conceptual model is just to show the reality. So it's basically a simplified version of the data that exists in the reality. And this model, the conceptual model, will be a great help when creating the database. Actually, the database will be very similar to the conceptual model, at least if we made a good conceptual model. So before we start with the conceptual model, a short repetition of the domain modeling method. So I guess you watched the videos on the domain, how to create a domain model, which is the same thing but related to programming instead of database design. But we will reuse this method, at least in big parts. That's why I'm covering it here. I mean, we will reuse it when creating the conceptual model. So the first thing was to do noun identification to find all nouns in the whatever requirement specification we have. And all nouns are candidates to become entities in the conceptual model. Then we use a category list to find more candidates for entities. Then we remove unnecessary classes, entities in the conceptual model, if there are any unnecessary entities. So the first two steps was to get candidates for entities or classes in the domain model. And the third step is to remove if we already now can see that some of them are not needed. Then find attributes and then find associations. So that was the domain modeling method in very brief, and you've seen it in greater detail in the video on domain modeling. Right, so what about forgot the last step, review. Of course, when we've done all this, we should review the model that we created and see if it can be refined somehow, perhaps redo some of the steps. Right, so we are going to use the same method basically now that we are about to create a conceptual model. But the difference is that in the domain model, the focus was mainly on classes or entities, if you wish. But now the focus is instead on data and relations. So this means that there will be some smaller differences to domain modeling. And the differences are that now there is, when creating the conceptual model, there is no point to have an entity without attributes, because the data is the attributes, and if the entity has no data, then there is nothing to model, because we are modeling data, right? Also that it's important to find all attributes, because the same reason. What we are modeling is data, and the data will go in the attributes. So finding all important data is to find all meaningful attributes. Yep, and for each of the attributes we define cardinality, that is how many values will this attribute have. Normally only one, but there could be some attribute that can have more values. For example, a person's phone numbers. The person could have more than one phone number. Also, we try to see if the attribute is allowed to be without value. I mean, could it be, is it a violation of some business rule if this attribute does not have a value? It is also important to find relations. The focus now, the conceptual model is supposed to illustrate data, and not only data, but also the relations between the data. So therefore it's important to find all relations. And it's also important to specify cardinality for all relations. That will be of big help when, as we will see later, when creating the database. So those are things that are more important now in the conceptual model than in the domain model. But we can still use the same method, keeping these 5 bullets in mind. Right, so let's move to an exercise. So the exercise is here. So this is the requirement specification that we're going to model. Okay, so a few words on requirement elicitation. So before we do any modeling, whether it's domain model or conceptual model or whatever, we have of course had a discussion with the customer and tried to together come up with a text or some kind of something that describes what is to be done. Maybe we create the model while talking. Maybe the customer wrote the text first and handed it over to us. And anyway, there is some kind of activity going on that with the scope of finding what is to be done, programmed or stored in the database or whatever. And this activity, finding what the customer wants, is a requirement elicitation, and that is completely outside this course. So we assume it has been done, and the result was very poor. It's this short text. Okay, what can we do? This is what we have, and this is the thing we are going to modeling. So the database shall illustrate how patients visit doctors at healthcare establishments, and the data must show which patient visited which doctor when and why the visit was done and where it was done, at which healthcare establishment. Right, so this is what we are going to do. So first of all, then, noun identification. Right, so I started Asta here. I've created a new project, and now let's create an ER diagram. ER diagram, and we use IE notation, and we have attribute visibility, and it's the logical model. That's fine. Okay, so now we can create entities. So we create one entity for each noun in the text. Pause the video, create one entity for each noun, and I will do the same. So I'm assuming you have made the noun identification now, and I will show my extremely exciting noun identification. If you have not, pause the video again if you wish. Okay, but anyway, let's look at my nouns. So I found 4. Patient, for example, here. Doctor, for example, here. Healthcare establishment, here. And the reason, here, reason. The reason why the visit was made. Right, of course, also a database is a noun, but that's really outside the requirement specification, right? I mean, it's here. The requirement specification is here, I'd say. The rest is just some introductory text. Like this. Okay, so I found 4. If you found more, good work. Okay, let's move on to. So, by the way, it's not that, I mean, when one first starts to model everything, it seems like whatever you write, it's wrong somehow, because there are so many things to consider, and it's not really, I mean, it's a matter of evaluation. It's not like when compiling a program, pass, fail, but here you can. There are things that can be done better and things that can be done worse. And whatever you do, it could have been done better. But don't worry too much in the beginning. Just get started. Creating a model is an iterative process. We do something, we refine it, we try another way, we refine it, and so on. So yeah, now we're started. So next step was to use the category list. Here is the category list used in the domain modeling video, and it's the same it exists in the book in chapter section 4.2 on domain model in the book that was linked in the domain model under the domain model video. As I wrote there, you are not supposed to read the book. It is sufficient to see the video, I guess. There's of course much more information in the book, but I guess you don't have your time is limited, right? Anyway, here are the categories, and the purpose of using the category list is to find more candidates for entities in order not to miss anything. If we miss an entity in the final conceptual model, it's not good at all, because it means we have missed all the data that belonged to that entity. If we miss it exactly now, maybe no disaster, because we might find it later when we start reviewing the domain model, and when we create attributes and the relations, maybe we'll see that something is missing. Anyway, let's start to use the category list. So first, we're going to look at the transactions. Actually, there are no transactions here, right? Nothing is sold or bought. Of course, it can be claimed that the customer pays for the visit to the doctor, and that is most likely true. But we are not supposed to model anything related to payment here, so therefore we leave out transactions. Products or services sold or bought, obviously no, since we consider that nothing is being sold or bought, then there are no products or services being sold or bought. Roles, yes, there are roles here, right? There are two roles. There is the patient and the doctor. So we could say that we found two roles in the category list, but it is of no use because both patient and doctor were already found using noun identification. And remember, the purpose of the category list is by no means to sort entities. With no point in writing patient and doctor here at roles, illustrating that they are roles. No, the only point of using the category list is to find entity candidates. Okay, we move on. Places. Are there any places involved here in this activity that is going on? There is actually, because well, I don't know if it's I was thinking, it says at which healthcare establishment, and I was thinking about address, and in that way a place identifying the healthcare establishment. Maybe this organization is not using addresses, but instead maybe more likely that each healthcare establishment has some kind of number, identifying number or whatever name maybe. That of course we should ask the customer. Anyway, let's not care too much about whether we should actually include this entity candidate that we found or not. We found one, so let's draw it, and it was address. There is a place, obviously there is a place. So address was added. We could also say, I don't know, it's again something that we should discuss with the customer, but we have a requirement that we should see who has visited and what data is relevant to this who. The who is of course the patient. What data to store about the patient, that we cannot guess or decide ourselves. It must be discussed with the customer, but potentially it could be of interest. It seems likely that it's of interest to know the patient's address. So okay, we have this address thing here. Right, but why is it an entity and not an attribute of healthcare establishment and patient, as I was arguing right now? It's because right now we don't care whether the thing we find is an attribute or an entity. We will think about that later. For now, we're just happy to find it. Right, where were we? We were at places. So we're done here, down to here. And now we are at records of a transaction. Contract, receipt, well, first there could be, well, okay, we decided already not to model payment, otherwise the patient might have got the receipt for the payment. Also, it might be that the doctor tells the patient to take some kind of medicine, or maybe go see some other healthcare establishment for some reason. And that is perhaps some kind of record of a transaction. Okay, but it's again a bit outside, I think, what is being modeled here. Okay, I mean, all these ambiguities appear, of course, because this requirement specification is extremely short, and then in reality, of course, no one would ever dream of designing a database with using such a very brief description. But let's try to stick to the description now. No, I mean, there's the danger that we start to create a medical record system for the entire, illustrating everything that happens to the patient everywhere at all healthcare establishments during the patient's entire life. And that's not the purpose here. In this simple exercise, we only model what's written. That's why now when using the category list, we find many potential entities that we exclude because they are outside this, or the exercise would become far too big. Right, so I'm trying to do this relatively quickly in order to not to make the video extremely long, but rather give an example of how to create a conceptual model. When doing this for the project or in reality or whatever, it takes much more time. Should take several hours. Maybe not this very brief exercise, but you should spend many hours for the conceptual model in the project, or it will not be properly done. Okay, we have arrived at events, and now I think you should again pause the video and try to see if there are any events, because there are, and as an exercise you can try to find events yourself. Right, so pause the video and try to find to create an entity related to events. Okay, so maybe you have now. So the event is the visit. And in many situations there are this kind of entity or class in a program, and it's easy to miss them, and that is a big mistake. The visit is actually the whole thing that's going on here. It's a very central concept in this situation. Everything is about the patient's visit to the doctor, so we most definitely will need an entity visit. I mean, should for some strange reason in the end not there be any attribute in the visit entity, then we didn't need it and we just remove it. But I think that's very unlikely, since the visit is such a very central thing here. So that's important. And again, I want to emphasize, you should really try to find such central entities. Okay, I will stop here in order not to make the video too long, I think. Okay, but in reality, with a bigger requirement specification and more time, you should spend a lot of time on the category list trying to find entities. So we have all our candidate entities. If you compare to the domain model in the domain modeling videos, they are quite few. But that's because even though that exercise was also short, I think the requirement specification is even shorter here. That's one important point. And the other important point is that in the conceptual model, the focus is on data, that is the attributes, not so much on entities. So we do not write all the candidate entities that we think might be that would reasonably be empty without attributes focuses on data. Okay, but there should have been more. Had we spent some more time on the category list, we could have found more, I'm quite sure. So we move to the next step. Remove unnecessary classes or entities. Well, since there were very few added, we didn't do it that thoroughly. I think there's nothing to remove here. Or is there? What do we say about reason? Reason is a rather abstract thing. It came from here. It's supposed to say why the patient went to see the doctor. That's it. Okay, so it's clearly stated here that this should be in the conceptual model, that we have to store data related to the reason, but maybe reason is not a very good name. We should maybe change it to what? Purpose of visit purpose. Naming things is very important, and very much time can be spent on coming up with good illustrative names. And it's better done, everything is better done under discussion. I'm 100% sure this model would have been better if we had discussed it during a lecture than instead of me doing it alone. So reason for visit, purpose of visit, illness, but maybe the patient is not coming exactly because of an illness, because the patient is ill, maybe instead, or some precaution in order not to get ill. How to call it? Is it the purpose? It's not a good name. Maybe you can come up with a better name. I don't feel that is a very good name. If you can come up with a better name, then great. Right, but now let's keep these 6 entities and we move to find attributes. But before looking for attributes, we must know what criteria there is to model something as an attribute. So one thing is that we can say an attribute must be either a string, Boolean, number, or time including date. So that's one way to define an attribute. They are like simpler. One thing that can be represented as either string, Boolean, number, or time. That's one way. No absolute rule, but it's one guideline for defining attributes. Another one is that, so you can say that this was guideline 1. Another one, number 2, is that attributes can not have attributes. Right, so even if something is can be considered to be, for example, a string, we can still not model it as an attribute if it is supposed to have attributes. And an example of this could be the address. So the address could be regarded as a string, and which would favor modeling it as an attribute, but it might always also be convenient to split the address into street, zip, and city, and in that case it cannot be considered an attribute since it has attributes. And third, attribute is not a part of not. Note that I wrote not here. NDT. So the keyword here is part. That is a common mistake, to model parts as attributes, but when you do that you are normally breaking rule number 1, so, or maybe we should call it guideline number 1. So number 3 here is to remind us of number 1, we could say. One example could be a house. So you should not give the house, have a window as an attribute to house, because window is a part and it's something more complex than just a string, boolean, number, or time. Maybe number of windows could be an attribute. That's a number. But window is not an attribute of house because it is a part. And that is proven by the fact that window cannot be represented by any of these basic types, string, boolean, number, time. Okay, so those are the guidelines for modeling attributes. So now pause the video and start modeling attributes. Let's make it a bit in smaller steps. Let's say that we start with patient. So try to model attributes only for the patient, and I will do the same. So this was my attempt at creating attributes for the patient. Name, person, number, phone, address, email. Of course, there's no right or wrong here. I mean, without talking to the customer. Maybe there is an absolute right or wrong. That's likely. But to reach there, we have to agree with the customer and discuss further. Right, but let's say that these are the attributes. Maybe you came up with something essential that I missed. In that case, that just proves that modeling must be done under discussion. Okay, now we are finding attributes, but now we have to view things that are a bit different for conceptual model. It is important to find all attributes. Okay, we don't know without talking with the customer. Let's say we found them all in order to keep the video brief, if nothing else. For each attribute, define cardinality and if the attribute is allowed to be without value. Let's do as I did in the video on IE notation and make a note. This is actually a note symbol, but it's UML note symbol, so it's not really correct to place it in the ER diagram. Okay, but you do as you wish. Now I will write a note here. Right, so let's think here. Name. Okay, name is an interesting thing. Of course, the person can have many names. For example, surname, first name, last name, can have middle names. Shall we say that it is just one long string? We don't care about. We don't divide the names. We just write in one string. That's a bit stupid, is it? Let's change it. First name. Last name. Okay, let's keep it like this. So first name, the person can have. Okay, of course the person can have many first names, but let's say that we consider them as being just one string, so that way the person can have just one name, one first name. Is it allowed to be null? That is, can we have a patient without a first name? If we don't know the first name of the patient, we are still allowed to examine the patient, I guess. Okay, again, this must of course be discussed with the customer, and we can keep on thinking about this for a long time, making the video very long, but let's just decide something. We can have a patient without a first name and also without a last name. Person number. Let's say that we are required to have a person number. Unfortunately, as you see, the fact that I checked this box here does not show, so one has to look at the attribute properties here to understand that it's not allowed to be null. We could make notes. I mean, the important thing anyway is to make it as clear as possible. The reader should understand. If you feel you're doing something that might be hard to understand, then add a note or whatever. Make sure the reader understands. So we could add a note here as well if we wish. Not null. So we can only attach the note actually to the class, not to an attribute, but by placing this dashed line close to person number, maybe we could illustrate that, or we could write the person number is not allowed to be null, or whatever. The important thing is that we make it as clear as possible. Okay, phone. So let's say that the person can have any number of phones. Phone actually should have the cardinality 0 to any number. The person can have any number of phones. And there's no way of writing this in Nasta, so I just added it as text close to the attribute. The address, so the address is actually an entity. So now we have to decide if the address should be an attribute or an entity, which is, do we want to split it in zip, street, city, and so on. Let's say we do, so we remove it from here. And we remember that there should be a reference from patient to address. Let's make a note so we don't forget it. Patient has an address, and we'll remove this note later when we add this relation between patient and address. There. Right, and email, the person may or may not have an email. Can they have more than one email address? Of course they can, but do we care, or are they forced to tell us just one? Let's say that they have to tell us just one. Okay, just to get some examples of the different kinds of attributes. So that was those were the attributes of patient. Far too quick. We should consider things much more carefully, but just to illustrate the reasoning that should be done. Okay, let's move on to doctor. What kind of attributes do the doctor have? So remember that we have to be able to tell which doctor the patient visited, and therefore we must have some kind of identification of the doctor. That is of course also something we must ask the customers. Let's say that the doctor has an employment number. Employment ID, we can say. The doctor reasonably also has a name and an address and an email address and so on. First name, last name. Actually, we can already now see that, let's remove this, because already now we realize that the doctor is going to have exactly the same attributes as the patient. First name, last name, person number, phone, email. The doctor, of course, has all these attributes. What to do with that? First of all, are they relevant for the doctor? Do we care about all these things for the doctor? Of course, the organization must know the person number and the phone number and so on of their doctors. But is that relevant in this situation? Okay, that's one question. If they are, do we want to duplicate? Do we want both the doctor and the patient to have first name, last name, person number, phone, email, and so on? Or do we wish to extract those to another table, for example, person? Does it matter? Maybe not that much for now, but there is another issue here that I realize now. And that is that the doctor can of course also become ill and go and visit another doctor. So the doctor can be a patient, right? If we move all these attributes to person, and then the doctor is a person of course, and the patient is a person. Okay, if there is a particular doctor which has a reference to a particular person and a patient which has a reference to the same particular person, then the doctor is a patient and is seeing some other Wait a minute. No, that's not correct. Aha, but now I think I understand. Yeah, now I got it. I think we do like this. We move all these attributes to person, and also the note, of course. Then now let's see. So the doctor is a person and the patient is a person. Either we are interested in who is the doctor here in this situation, and then we look at the doctor and maybe we fetch the doctor's data from the person table, or we are trying to understand who is the patient, and then we fetch the patient's data from the person entity. We don't really care if the patient, when a certain person is a patient and is seeing a doctor, we don't care about the profession of the patient. So whether the patient is also a doctor or not is not of importance in that situation. So we don't have to understand. There's no need for some kind of reference or way to find out if a certain doctor is a patient in another situation. We're only interested in at each specific visit, the doctor and the patient. Okay, so now the question is, the patient is empty, and we don't want, as was stated, no point in an entity without attributes. So does the patient have any attributes, or can we remove the patient completely? Does the patient have some kind of patient number? Probably not. Probably there is just the person number. Right, but so then we should remove the patient entity. Then we have person and doctor. Of course, the doctor is a person. Doctor and person, but then do we understand that now we're going in circles? Then if the doctor is a person, right, then at each visit there is a doctor and a person, and the doctor is a person. The doctor has a reference to person, and at the visit there is a person and a doctor. And we find information about the doctor from the person. Yes, maybe that will work. Then one can argue, let's rename the person to patient, and we're back where we started, but that's not good, because doctor will always be a patient. Even the doctor, when the doctor acts as a doctor, will be a patient, which is not okay. I think it will sort out this way. We remove patient. Yeah, and the fact that this person is a patient at the visit will be obvious by the name of the rows and by name of attributes. I think so. Let's try that way. Okay, that's that. Let's quickly add some attributes. Okay, maybe we could decide that maybe we say it's important that the employment ID is unique. We can specify uniqueness of an attribute by checking primary key, but then it jumps up here and it becomes this is important, and this has a meaning in the database. It will be identifier of a table named doctor, and we don't want to think about databases now, so maybe we can specify here that like this, unique. Then of course we could write for person number here also as well, not null. Maybe that's better than putting this note. It doesn't matter. Try to make none of this is correct IE notation. In IE notation there are other symbols that should be placed that are not supported by ASTA. So just make it as easy to understand as possible. You decide how. If any ambiguity, write explaining text or add a note. Okay, that's that. Let's move on. And address. say that the address has a street, the address has a zip code, and the address has a city. There. And let's say that the healthcare establishment has an healthcare establishment ID, and the visit purpose has a description, free text, description, entity, that was some kind of mistake, and the visit. Does the visit have any kind of visit number or something, or is it empty? Okay, if it's empty, then we are in the danger zone, because we might be tempted to remove it. But we have just concluded that visit is important here, and visit will in fact be used to connect a doctor and the person, but the visit does have attributes because it has a time, right? It takes place at a particular time, and in fact we can see that our database must show when the visit took place. But what if there had not been, if we had not had the requirement to show at which time, would be quite stupid, but let's just assume that there was no requirement to show when the visit was made. Would that mean that we should remove the visit entity? Probably not. Okay, if we don't have the visit entity, then we will have some kind of relations between these other four representing a visit, but we will not be able to identify a unique visit. It will be a record of all visits that the patient has ever made. I think the answer is simply that if we want to model each visit, each individual visit, then that visit also has a time. It must have some property that makes it unique from other visits, or it is not a unique visit. We cannot just call it visit 1, 2, 3. Well, then it has an ID 1, 2, 3. Okay, so the answer to this discussion is that visit has a time, and therefore it must have a time, and therefore is not empty. It must have some kind of identifying attribute. Okay, so anyway, we are done with attributes. Well, we are not really done, because we have not considered the cardinality and uniqueness and nullness of each attribute, but I won't do that. Now I've illustrated the reasoning that must be done. Attributes found, and we have handled them, and then find associations, or rather relations, since it is an ER diagram. So we have to make sure to find all relations, and we should specify cardinality for all relations. And just as in the domain model, we should also try to give a name to all relations. Right, so that's the next thing that we shall do, have a look at relations.